Hello everyone, in this video we are going to learn about the hyperbola. What is a hyperbola? What is its analytical definition? What is the standard form and the standard equation of a hyperbola and how to get it? And also how to find out the latus rectum of a hyperbola. We have already known and understood in the video for the introduction of the conic sections that hyperbola is a conic section cut by a plane from the double cone. In case we want to know about the analytical equation of a hyperbola, we say that it is the locus of point which moves such that its distance from a fixed point S, which we call as the focus, is greater than the distance of the point from a fixed line, which is known as the directrix, is a hyperbola. Now, what is the standard form of it? In case we have two axes of the hyperbola along the x-axis and y-axis, then we say it is a standard form of the hyperbola. Here we see this is the hyperbola AA dash, which are intersecting this particular x-axis are known as its vertices. And AA dash is known as its transverse axis, which is along the x-axis. And the length of transverse axis is taken as 2a. Perpendicular to this transverse axis is one of the axes, which is BB dash. It is known as the conjugate axis. And the length of it is taken as 2b. There are two foci of it. They are on the x-axis. And we find that the foci are S is having the coordinates AE, 0 and S dash is minus AE, 0. Where we know that E is the eccentricity of the hyperbola. Now we see from the analytical definition that PS is greater than PM. PS is greater than PM. It means PS upon PM is greater than 1. And we know this PS upon PM is only known as the eccentricity of the hyperbola. There are two directrices of the hyperbola which are parallel to the y-axis. And they are x equal to plus minus A upon E. Now we'll learn how to find out the standard equation of a hyperbola. To find the standard equation of the hyperbola, see where is the center of it. Center we know is the point which bisects every chord of the conic section, and here O, that is origin, is the center of the hyperbola. Now if we take any arbitrary point P whose coordinates are x, y on the hyperbola, then according to the definition we have PS upon PM is equal to E. It means PS will be equal to E into PM. Now if we find the distance PS by distance formula, we can see the distance between the focus and the point, that will be x minus AE whole square plus y minus 0 whole square root of it is equal to E into PM. What is PM? To see here PM, we can see here PM is equal to RQ or not? Can we write RQ as OQ minus OR? OQ is the x coordinate to this point P, that will be x. Minus, what is OR? OR is the distance of the directrix from the origin. That is A upon E. It means that comes as x minus A upon E. If we substitute that value here, this will be E into x minus A upon E. Simplifying which, we are getting EX minus A. Now if we square both the sides, are we getting x square minus 2AEX plus A square E square plus y square equal to E square x square minus 2AEX plus A square. We know the perfect square of A minus B. We find here 2AEX and 2AEX cancel. Now using the transposition we get here a square e square minus a square is equal to e square x square minus x square minus y square. Taking common here a square, we are getting e square minus 1. Here x square is common, this is e square minus 1 minus y square. If we divide both the sides by this a square into e square minus 1, we are getting here 1 equal to x square into e square minus 1 upon a square into e square minus 1 minus y square upon a square into e square minus 1. This e square minus 1 cancels this here. It means we are getting here this is x square upon a square minus y square upon a square into e square minus 1, which is equal to b square is equal to 1. This is the standard equation of the hyperbola. That is x square upon e square minus y square upon b square is equal to 1. Now we learn how to find out the length of latus rectum of the hyperbola. We know that the latus rectum of a conic section is the double ordinate through the focus of it. Or we say it is a chord which is perpendicular to the main axis. Here it is the transverse axis and passing through the focus. So here we take L dash is the latus rectum. So here latus rectum is L dash. Let the length of this be 2k. If length is 2k, this is equal on both the sides of this because hyperbola is symmetric about the x-axis. So we can say that this gives us SL is equal to SL dash and that is equal to k. Now can we say that the coordinates of L will be AE comma k and that of L dash will be AE comma minus k. Both the points are lying on the hyperbola and we know the equation of hyperbola is x square upon a square minus y square upon b square is equal to 1. L lies on it. If we substitute that value of x and y as AE and k here, will we get x means AE whole square upon a square minus y means k, that is k square upon b square is equal to 1. Are we getting here a square e square upon a square minus k square upon b square is equal to 1? This a square and a square cancel. Are we getting here then k square upon b square is equal to e square minus 1? We have transposed this on that side and 1 on this side. And we know from the relation b square is equal to a square into e square minus 1. E square minus 1 is equal to b square upon a square. If we substitute that value here, are we getting k square upon b square is equal to b square upon a square? Or we can say that k square is equal to b to the power 4 upon a square. So we are getting the value of k as b square upon a. So we are getting the length of latus rectum will be equal to 2k and that is equal to 2 into b square upon a. By applying this formula, we can find out the length of latus rectum of the standard hyperbola. Some of the properties of the hyperbola are, number 1, the hyperbola is symmetric about its both the axes, that is transverse axis and the conjugate axis. Here in the case of standard form, it is symmetric about the x-axis and y-axis. Also we can see in the equation if we substitute minus x in place of x and minus y in place of y, the equation is unchanged. So it is symmetric about the x-axis and the y-axis both. The second property is that the difference of the focal distances of a point on the hyperbola is equal to the length of transverse axis. It means here we can say PS dash minus PS is equal to 2a, because 2 is the length of the transverse axis. And the third point is the relation between a and b, as we have already used it, that is b square is equal to a square into e square minus 1, where e is the eccentricity of the hyperbola. In the next video we will continue the same, and we will learn about the conjugate hyperbola, what is conjugate hyperbola and what is the equation of it, and also we will do some of the examples based on the standard form of the equations of the hyperbola. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.